Okay, let's do some examples in which we evaluate the given sums. Starting from the first one. This is I going from 1 to n, 2 over n times 1 minus 2i over n squared. One thing here to note, which will happen in the other examples also, that here what you see n is just a constant. It can be 10, 100, 2000, anything. So these guys, the variable here, the summing variable is I. So this n has nothing to do with I. So if you want to evaluate these guys, first we have to simplify and write them as sums of powers of integers. Here, for example, 2 over n is just a constant. I can put it outside of the summation. And this is the identity, 1 squared plus 2 times 2i over n times 1. So it will be 4 over n times I plus the second term squared. From here, then we have 2 over n. We can separate these guys, yes. Sum of 1 plus 2 over n times, well, there's a 4 over n also here. I can multiply that outside, 4 over n. Then I going from 1 to n of I plus, there's 2 over n there. There's 4 over n squared there. Then multiply to I going from 1 to n I squared. Now, you see the summation parts that are not evaluated yet, we have formula for. Sum of 1 from 1 to n is just n plus. This is 8 over n squared. Sum of integers, just I from 1 to n is n times n plus 1 over 2. Plus, here's 8 over n cubed, and sums of squares of integers from 1 to n is n times n plus 1. These are the formulas you have to learn, and you can find them in the previous video. Well, you can simplify these guys. For example, you see this cancels with that. You can write 2. One of these cancel with that. You get 4 here. This will be 4 times n plus 1 over n. Like that. And one of these cancel with that. This and that. You get 4 over 3. So 4 over 3 times n plus 1. 2n plus 1 over n squared. So that's what you can simplify more, but that's what I need at this stage. Very nice. The second example, again, we have some n. This is just a constant, some i's in there. And one of the issues that we have is that I, instead of starting from 1, starts from 3. So it means that we have to rewrite this thing with a new index starting from 1. How do we do that? Well, let j to be I minus 3 plus 1, which is minus 2. In that case, when I is 3, the starting point, then j would be 3 minus 2, which is 1. So j starts from there. When I gets to n, j would be n minus 2. So the end point would be n minus 2. And wherever you see I minus 2, you replace it by j. And whenever you see I, you can replace it by j plus 2. So this will be j plus 2 over n times I minus 2 itself is just j. So it will be j squared here. Now, I can put 1 over n out, and this will be j cubed. J going from 1 to n minus 2, plus this will be 1 over n times 2 j squared. Let me put 2 also out. And this will go j from 1n minus 2 j squared. Now we have the formulas. Sums of cube of the integers from 1 to n is n squared plus n plus 1 squared over 4. But this goes up to n minus 2. So it will be n minus 2 squared, n minus 2 plus 1 squared over 4 plus 2 over n. Sums of j squared, j going from 1 to n minus 2. This will be n minus 2 times n minus 2 plus 1, 2n minus 2 plus 1 over 6. And that's what we need to have in this case. You can simplify a little bit more, but basically that's the formula. Let me just write a little bit more simplified version. For example, this will be 4n n minus 2 squared, and then this is n minus 1 squared, plus this will be 3n in the denominator, n minus 2, n minus 1, and then 2n minus 3. That's the other term that we have there. Very nice. How about this one? Remember that we have sum of r to the power n, r to the power I going from 1 to n is given by r minus r to the power n plus 1 over 1 minus r. So here, this is a little bit more complicated than just r to the power I. But what we can do, we can turn it into such things. So first is that we get rid of that 3 by applying this rule here. And you see, this is just 8. This is constant. I can put it outside. And 2 to the power 2i over n, I can write it as 2 to the power 2n to the power I going from 1 to n. And now this is r. This is what we wanted to have as r. And this will give us 8 times r, which is, what this is r, 2 to the power 2 over n minus 2 to the power 2 over n to the power n plus 1, the last index plus 1, over 1 minus 2 to the power 2 over n, 1 minus r. We can simplify this thing again a little bit. For example, we can write this as 8 times 1 minus, you see, 2 to the power 2 over n. This is nth root of 4. And this is nth root of 4 minus. Here we have 4 to the power n plus 1 over n, which is nth root of this guy. Maybe a little bit simplified version. But as you see, you need to know the geometric series. You need to know sums of powers of integers to be able to evaluate these kind of sums.